All right, in this video, we're going to talk about section 13.4, dealing with surface area. And we're going to be finding surface areas of solids, also solving applications involving surface area of solids, and find dimensions of solids with given surface areas. Okay. Excuse me. All right. Now, painting houses, buying roofing, seal coating driveways, and buying carpet are among the common applications that involve computing areas. And in many real-world problems, we must find the surface areas of such three-dimensional figures such as prisms, cylinders, pyramids, cones, and spheres. Formulas for finding these areas are usually based on finding the area of two-dimensional pieces of three-dimensional figures, okay? So now, when we're dealing with surface area, we're going to be dealing with two types of area. One of them, of course, will be, well, we're going to talk about the lateral surface area. That's in this case going to be the sum of the areas of the lateral faces. So for example, let's say I have this box right here that I'm going to put on the screen. And that's this right here. And this will be an example of a rectangular prism. So if I'm dealing with the lateral surface area, I'm pretty much dealing with the area in the front, the back, the left side, and the right side. The right side, here you go. All right, those are called lateral faces. Okay, now the top and the bottom are usually going to be considered to be your bases. Okay, so the surface area, by definition, is going to be the sum of the lateral surface area and the area of the bases, which are the top and the bottom. So in this case, it's like for a cube, the figure on the top and the figure on the bottom are your bases. The other four faces are going to compile the lateral surface area. And if you were to flatten that cube out into to something that's called a net, you'll see that it would look like this in two dimensions. Now, the formula for finding the area of the surface area of a cube would be 6e squared. And in this case, your e is going to be the edge of that cube, or the length of the edge of the cube, or we can call that the side of that cube. So if you look on the next page, you're going to see one example that deals with just calculating the surface area of a cube. And in this case, you can see that the edge, each edge has a length of 11 centimeters. So your E, which is your edge, that will be 11 centimeters. Okay. So to find the surface area, and I'm going to abbreviate SA for surface area. That's, of course, 6e squared. And your edge is 11 centimeters. So this will just be 6 times 11 centimeters, and that's going to be squared. Then I'm going to bring down the 6 and then square the 11. 11 squared is 11 times 11. That's 121. And this will be centimeters squared. Keep in mind, area is always going to be in some form of a square unit, like square centimeters, square yards, square inches, square feet. And then 6 times the 121 will end up being 726. And this is in square centimeters. So the surface area of that cube would be 726 square centimeters. Okay. Excuse me. All right, now example number 2. Two cubes have sides of length 5 centimeters and 8 centimeters. What is the ratio of their respective surface area? Okay, so for that first cube, the surface area, of course, is 6e squared. So this will be 6 times, let's say that first cube is 5 centimeters. So it'll be 6 times 5 centimeters, and that's going to be squared. So if I square that 5 centimeters, that means 5 squared will be 25. And that'd be square centimeters. And then 6 times 25 would be 150 square centimeters. So the first cube has a surface area of, of 150 square centimeters. And then the second cube has a side of 8 centimeters. So that surface area would be equal to 6 times, and then I have to square the 8. Square that 8, that'll be 8 times 8, that'll be 64. And then 6 times 64 would be 384 square centimeters. Excuse me. So that means here that for the second cube, that surface area will be 384 cubic centimeters. Now for the ratio of the first cube to the second, I'll write that as a fraction. That'd be 150 over 384. And to write that in simplest form, I can pretty much use a calculator and find a number that would go into 150 and 384. Now we'll divide the numerator by 6 and the denominator by 6. So that means this will be 25 over 6 into 384 would go 64. So that ratio in this case would be 25 to 64. Now you could have easily gotten that ratio by doing this. Square the 5, which is 25, and then square the 8. That would be 64. All right, example 3. I'm only going to do part A. I'm going to omit part B. So I'm going to put the word omit on this one and just only do part A. The total surface area of a cube is 11,331 square centimeters. What is the length of one of the sides? So that's part A. And of course, the surface area is, of course, 6e, and that's squared. That's a formula for finding the surface area of a cube. And we're told that the total surface area is 11,331. And that's going to be equal to 6e squared. Now, if I divide both sides by 6 to get the e squared by itself, that means e squared will be, and this is what I come up with, 1,888.5. And then to solve for e, if it's squared, the opposite of squaring something would be to take the square root of 1,888.5. And let's say I want to round this off to the nearest whole number. Okay. And I will tell you when I do its square root. Let's see, 1,888.5. And then if I do the square root, I'm going to get approximately 43.45. But let's say I want to round that to the nearest whole number. It will be 43. And this will be in centimeters since the edge is since that surface area is in square centimeters, the edge of that cube has to be in centimeters. So the edge of that cube will be approximately 43 centimeters. Okay. Part B, I'm omitting. Okay. All right, next we'll look at the surface area of a right prism. Okay, and here's the formula. If capital B stands for the area of each of the prism bases, and the bases are going to be the top and the bottom, in this case, the surface area of the prism could be computed as this. Here, the surface area there will be P times H plus 2 times B. Now, the P is going to be the perimeter of the base. If you recall, anytime you find a perimeter of any figure, you have to add the lengths together. And also, your height is going to be H, and B is going to be the area of the base. And it depends upon what type of base you have. If it's a rectangle, you have to calculate the area of the base of that rectangle by using length times width. Or if it's a triangle, the area of the triangle is going to be 1/2 the base times the height. Okay, and if you're not familiar with those formulas for finding the area of two-dimensional figures, I will have a YouTube video posted in Blackboard, which is going to act as a supplement to what I'm teaching here in this video. So do refer to that if necessary. Okay. Now, in this example here, let's say we want to find the surface area of the right rectangular prism below, okay? And the basis, of course, is a rectangle, all right? So when you find the perimeter of a rectangle, that's always 2 times the length plus 2 times the width. So this will be your length, and this will be your width. Your length is 9 centimeters. The width is 6 centimeters. So I'm gonna have 2 times 9 plus 2 times 6. Okay, this is your length, this is the width, and that 7 is gonna be the height. All right, so 2 times 9 will be 18, plus 2 times 6 will be 12. 18 plus 12 will be 30. And this is 30 centimeters for the perimeter of that base. The height, of course, I did mention that, that's 7 centimeters. Now, capital B is going to be the area of the base. Here, the base is a rectangle, so the formula for finding the area of any rectangle will be length times width. And here the length is 9 centimeters times the width, which is 6 centimeters. So 9 times 6 will be 54. So the base will be 54 square centimeters. All right. So now I can find what the surface area is of this right regular prism or right rectangular prism. That's going to be P times H plus 2 times the base. And in this case, your perimeter, we found that out to be 30 centimeters times the height, that's 7 centimeters, plus 2 times the base, which is the area of the rectangular base, that's 54 square centimeters. Now, if I do 30 times 7, that will be 210. That's going to be square centimeters, plus 2 times 54 square centimeters will be 108 square centimeters. So 210 square centimeters plus 108 square centimeters will be 318 square centimeters. Okay, that represents the surface area of the right rectangular prism. Okay. All right, suppose we had a right triangular prism. A right triangular prism. And I want to find its surface area. At this time, the base is a triangle. So now the perimeter of that triangle, notice I have lengths 3, 4, and 5. So I just add those lengths, 3 plus 4 plus 5. And that would give me 12 centimeters. 12 centimeters. And then next, I'm going to identify the height. So here's the height right here going straight up and down. That's 10 centimeters. So the height is 10 centimeters. And then this time the base. The base is a triangle. The base on this prism is in the form of a triangle. So the area of a triangle will be 1/2 its base times the height. Now you have to know which one's the base and which one's the height. I can tell you that the height is always going to be perpendicular to the base. So that means that this base has to be 3 centimeters and this height has to be 4. Because the base and the height are always perpendicular to each other, meaning that they form a 90-degree angle. So this will be 1/2. The base is going to be 3 centimeters times the height, which is 4 centimeters. So if I do, let's say 3 times 4 will be 12, and half of 12 will be 6. So that base is going to be 6 square centimeters. And from here, I can find the surface area of that right triangular prism. That's going to be the perimeter times the height plus 2 times the base. And in this case, my perimeter was 12 centimeters times the height, which is 10 centimeters, plus 2 times the base, which is 6 square centimeters. That's the base area of the triangle. Now simplify this to 12 times 10 will be 120 square centimeters, plus 2 times 6 will be 12 square centimeters. 120 square centimeters and 12 square centimeters added together will be 132 square centimeters. So that would be the surface area of the right triangular prism. Okay. All right, now on the next page is an application problem related to a rectangular prism. It says here, how many liters of paint must you buy to paint the walls of a rectangular prism-shaped room that is 15 meters by 11 meters with a ceiling height of 8 meters if 1 liter of paint covers 40 square meters? And we're to assume that there are no doors or windows and paint comes in 1 liter cans. All right, so here we're just painting the walls. We're not painting the floor and we're not going to paint the ceiling. Okay, so the way this surface area is going to work, and it's actually going to be the lateral surface area, which I'm going to abbreviate LSA for lateral surface area. That's just going to be the perimeter times the height. Okay, so if you were to look at that formula, I want to go back to this for a right prism, that P times H, that's actually the lateral surface area. That's the lateral surface area, P times H. And that 2B, That's the area of the bases, the top and the bottom. So we're only looking for the lateral surface area, which is, of course, LSA, as I'm abbreviating this. Now, the P, of course, is your perimeter. Now, of course, the perimeter is, of course, 2 times the length plus 2 times the width. And notice here, 15 meters by 11 meters. So that means your length is 15 meters and your width is 11 meters. The height is 8 meters. So to find that perimeter, that's going to be P is equal to 2 times your length, which is 15 meters, plus 2 times the width, which is 11 meters. 2 times 15 is 30 meters. 2 times 11 would be 22 meters. 30 and 22 adds up to 52. So the perimeter is going to be 52 meters. And our height is just plain 8 meters. So to find that lateral surface area, we multiply 52 meters by the height, which is 8 meters. Okay. So 52 times 8 would be 416. And this will be in square meters. So the lateral surface area would just be 416 square meters. And then we're going to find out how many liters of paint that we need to buy. And we're assuming that 1 liter of paint covers 40 square meters. Well, I'm going to take that 416 square meters, multiply that by, it takes, for 1 liter, it will take 40 square meters. Notice I'm putting the 40 square meters on the bottom and the 1 liter on top. That way these square meters divide out. So I'll have 416 divided by 40, and that will be in liters. And let's say I want to round up to the nearest whole number. So if I do 416 divided by 40, it's going to give me 10.4. But rounded up to the nearest whole number, it will have to be 11 liters. So I would need 11 liters of paint to paint the walls of a rectangular prism shaped room that's 15 meters by 11 meters with a ceiling height of 8 meters. Okay. All right, next we'll look at a surface area of a cylinder. And you're going to have to think of a soda can as a way of, as an illustration of a cylinder. As the number of sides of a right regular prism increases, the figure approaches the shape of a right circular cylinder. So we increase the number of sides here infinitely, we're going to get to a right circular cylinder. Okay. Now, for the surface area of a right circular cylinder, it's going to be 2 pi r squared plus 2 pi r h. Now, if you flatten out that right circular cylinder, it will end up like this. As you can see, your bases are going to be the 2 circles here, the top and the bottom. The area of a circle is always going to be pi times the radius squared. So, and you got 2 circles here, so that's where the 2 pi r squared comes from. And then 2 pi r h, that 2 pi r, that is the distance, that's the length of that circle right there. Because if you recall, the circumference is the length of the entire circle, and its circumference is going to be 2 pi r, 2 pi times the radius, and then you have your height, 2 pi r times h. Now, let me mention that this 2 pi RH, that is your lateral surface area. Lateral surface area. Whereas that 2 pi R squared, that represents the area of the basis. Which is, of course, the top and the bottom. All right, so now let's look at this next example, finding the surface area of the right circular cylinder below. So here we have a right circular cylinder with a radius of 3 centimeters. So here, this is the radius, which is 3 centimeters. And the height goes up and down, that's 21 centimeters. All right, so now we'll use the formula for finding the surface area. And that's going to be equal to 2 pi R squared plus 2 pi R times H. Now we're going to leave our answer in terms of pi. So when we substitute the R with 3 and the H with 11, we'll have 2 pi times R, which is 3 centimeters, and that's squared, plus 2 pi times the radius, which is 3 centimeters, times the height, which is 21 centimeters. Now let's simplify this. 3 squared is 3 times 3, which is the 9. 9 times the 2 pi will be 18 pi. And this will be in square centimeters. And then 2 times 3 will be 6. 6 times 21 will be 126 pi. And then square centimeters. So now 18 pi square centimeters plus 126 pi square centimeters will end up being 144 pi square centimeters. So that is the surface area of that right circular cylinder. Okay. All right, here's another example here. A soup can has 2 3/8 inch, has a 2 3/8 inch diameter and is 5 inches tall. What is the area of the paper that will be used to make the label of the can if the paper covers the entire lateral surface area? And we're going to use 3.14159 for pi. Okay, so in this case here, for a can, if you have any idea or picture what a can is, what it looks like, but there's paper around it that covers the lateral surface area of the can. So actually, we're looking for the lateral surface area. And if you recall, for a cylinder, when you're dealing with the lateral surface area, that's just going to be 2 pi R times H. So we have to use 2 pi R times H. Now we're given a diameter of 2 3/8 inches. Now the radius is always 1/2 the diameter. So that means I need to take 1/2 of 2 3/8. But you know what? I'm going to change that 2 3/8 to a decimal. So if I do, let's see, I'm going to clear this out. I'm going to do 3 divided by 8. That'd be 0.375, and then add 2 to it. That would be 2.375. And if I take half of 2.375, that's just like dividing by 2, which would be 1.1875. So that's actually the radius here, because the lateral surface area calls for the length of that radius, and I know the diameter. So to find the radius, you have to take 1/2 the diameter. So my radius is going to be 1.1875. And of course, the height was 5 inches tall. That's your height. And I'll go ahead and add the units here as well. All right, so now my lateral surface area will be this. 2 times, I'm going to use 3.14159 for pi times the radius, which was 1.1875, times the height, which is 5. Okay. And if I multiply 2 times 3.14159 times 1.1875 times 5, my final answer will be to 2 decimal places, 37.31. And this is in inches, so the area has to be in square inches. So that would be the lateral surface area. Okay, so in other words, that's going to be the area of the paper that will be used to make the label of the can if the paper covers the entire lateral surface area. Okay. All right, here's another example similar to that. If the cardboard tube of a toilet paper roll has a diameter of 2.38 inches and is 6 inches tall, what is the lateral surface area of the cardboard roll? Okay, so in this case here, again, we're finding the lateral surface area. And that roll of toilet paper is like a cylinder, so the lateral surface area of that cylinder will be 2 pi r times h. But here we know the diameter is 2.38 inches. So I have to take 1/2 the diameter to get my radius. So it'll be 1/2 of 2.38. And half of 2.38 will be 1.19. And this is in inches. So the radius is 1.19 inches. Now here we're going to give our answer in terms of pi. So here I'm going to do 2 pi times the radius, which is 1.19, times the height, that's 6. So 2 times 1.19 times 6, I get 14.28. Bring down the pi because I'm leaving my answer in terms of pi. And of course, area has to be in square units. So the lateral surface area will be 14.28 pi square inches. That's the lateral surface area of the cardboard roll. Right, on the next page, we're going to look at the surface area of a pyramid. A right regular pyramid is a pyramid such that the segments connecting the apex, which is the tip of that pyramid right at the top, such that the segments connecting the apex to each vertex of the base are congruent, and the base is a regular polygon. So here we have a regular polygon here at the bottom. And if you were to flatten it out, it would look like this. So here you will have pretty much these 4 triangles. Your base is going to be the square. Now, when we find the surface area for a right regular pyramid is going to be this. The surface area will be equal to N times 1/2 B times L plus B. Now, N is the number of faces, and L is going to be the slant height. And what the slant height means is this. If I go back to that figure, it's going to be the height that is on the face of the pyramid. There's a difference between a slant height and a vertical height. The vertical height goes straight up and down. It's always perpendicular. Well, it goes from the tip to the center. But a slant height is going to be on the face of that pyramid, perpendicular to one of the sides of that base. Lowercase b will be the length of each side of the base, which is right here, the length of each side of the base. Capital B will be the area of the base. And then the formula for the surface area of a right regular pyramid can be simplified because N times B is the perimeter itself. So we can use P in place of that. So we can simplify it as this: the surface area is equal to 1/2 the perimeter of the base times the slant height plus the area of the base. So we're going to use that formula with this example, and that is to find the surface area of the pyramid. All right, in this case here, we have a right square pyramid where, in this case, our base is a square. So in this case here, if we find the perimeter of that square, that's always 4 times S, because the square has 4 sides, 4 equal sides to be exact. Each side is 4 centimeters. So if I do 4 times 4 centimeters, that perimeter of that base will be 16 centimeters. And L will be the slant height. That's the height on the face of the pyramid. As you can see, it's 5 centimeters. And the area of the base, it is a square. So the formula for finding the area of a square is going to be the square of that side. And the length of that side is 4 centimeters. So if I square the 4, that's going to be 16 square centimeters. Now I have what I need to find the surface area of that right square pyramid. That's going to be 1/2 the perimeter times the slant height plus the base. So here I have 1/2. The perimeter was 16 centimeters. The slant height was 5 centimeters. Plus the base, 16 square centimeters. All right, half of 16 is 8. 8 times 5 will be 40. So this is 40 square centimeters plus 16 square centimeters. That adds up to 56 square centimeters. So in this case here, the surface area of that pyramid is 56 square centimeters. Okay. All right, now I'm going to omit number 11. So don't worry about that. All right, let's talk about the surface area of a cone. And that's this: as the number of sides of a right pyramid increases, the figure gets closer and closer to the shape of a right circular cone. Okay. So if I let the base, the number of sides on the base, increase infinitely, I will end up with a right circular cone. And the surface area for a right circular cone is going to be pi r squared plus pi r L. And of course, the L is the slant height. That's the height on the face of that cone. Do not get that confused with this height here that goes from the apex to the center of that circle. R is the radius of the circle that goes from the center to a point on that circle. Okay, so now let's look at, well, here's an illustration of that on the next page. If you were to flatten it out, it will look like this. All right, now in this example, let's say I want to find the surface area of the cone, which is this. Now notice I have a radius of 3 centimeters, so R is going to be 3 centimeters. The vertical height, that's actually going to be H. That's going to be 4 centimeters. Now, unfortunately, you're not going to need that with the surface area, but you do need to know what that slant height is. That's going to be the height on the face of that cone going this way. That's why it's slant, as you can see. It's 5 centimeters. So now to find the surface area, that's going to be pi r squared plus pi times r times the slant height. And our answer is going to be in terms of pi. So I'm going to bring down the pi, and here the radius is 3 centimeters. That will be squared plus pi times the radius again, that's 3 centimeters, times the slant height. That would be 5 centimeters. Now here we're not using that 4 centimeters here. That's the vertical height. The slant height is slant, like this. Now if I simplify this, 3 squared will be 9, so it'll be 9 pi, and that will be in square centimeters, plus 3 times 5 will be 15, so I have 15 pi. That 2 is going to be in square centimeters. 9 pi square centimeters and 15 pi square centimeters will be 24 pi square centimeters. Okay. All right, now let's look at this example right here. Let's say I want to find the surface area of the right circular cone below. Well, I know something here. I know the radius is 16 centimeters. I need to know what the slant height is. In other words, I need to know what this length of that slant height, that's the length on the face of that cone, is going to be. I can use what they call the Pythagorean theorem, because if I take this part out like this, I have a right triangle. And I know this vertical height, that's 12 centimeters. And I know that radius is 16 centimeters. So what I'm going to use here is the Pythagorean theorem. And of course, the Pythagorean theorem is this. And that's my slant height that I'm trying to find. C squared is equal to A squared plus B squared. This is my hypotenuse, which is C. That's what I'm trying to find. And I'll label that as L, so it'll be L squared is equal to A, that's 16 centimeters. So it'll be 16 squared, plus B, that's this height here, that's 12, so that'll be 12 squared. Now, if I square the 16, that's 16 times 16, which is 256, plus 12 times 12, that's 144. L squared will be this. 256 plus 144, if I add that together, that'll be 400. Now to find out what L is, I need to take the square root of 400. Because the opposite of squaring something would be to take the square root. So the square root of 400 would be 20. So L in this case would be equal to 20. And that L represents the slant height. So L is 20 centimeters. And now I can go ahead and find the surface area, which is of course pi r squared plus pi r times L. And again, we're going to leave our final answer in terms of pi. So I'm going to bring down the pi times, the radius is 16 centimeters, and that's squared, plus pi times the radius, again, that's 16 centimeters, times L, that's 20 centimeters. All right, 16 squared is 16 times 16, that's 256. So it'll be 256 pi square centimeters, plus 16 times 20 is 320. So I have 320 pi square centimeters. All right, 256 pi plus 320 pi will end up being 576 pi. And that area is in square centimeters, since our units are in centimeters. So the surface area of that right circular cone would be 576 pi square centimeters. Okay. And finally, we will look at the surface area of a sphere. That's the last thing we'll look at in this video. A great circle of a sphere is a circle on the sphere whose radius is equal to the radius of the sphere. It is the intersection of a plane through the center of the sphere and the sphere itself. So this shaded part right here is the great circle, as you can see. And the sphere, you have to think of a ball or a basketball in, any type of a sports ball would be in the shape of a sphere. A baseball or a golf ball or a basketball, those will be shapes of spheres. Now the surface area for a sphere would be 4 times pi times the radius squared. Okay. And here's an example of a sphere. And all we need to do there is just find the surface area of that sphere. And in this case, we have a radius of 2 centimeters. And that's all we need to find out what the surface area is going to be, which will be 4 pi times the square of the radius. Now we're going to leave the answer in terms of pi. So it'll be 4 pi times the radius, which is 2 centimeters, and that's squared. 2 squared, or 2 times 2, would be 4. And that will be in square centimeters. 4 pi times 4 will be 16 pi. And that's in square centimeters. So the surface area of that sphere will be 16 pi square centimeters. Okay. And here's another example, just an application problem related to the sphere and finding its surface area. Assume the radius of a certain planet is 2,420 kilometers and the planet is a sphere. What is its surface area? So already we know what the radius is, 2,420 kilometers. And we want the surface area. So the surface area there will be 4 pi times the square of the radius. And again, we're going to leave the answer in terms of pi. So it'll be 4 pi times 2,420 kilometers, and that's squared. Bring down the 4 pi. But if I square 2,420, I get, okay, let me do this on the calculator because that'd be 5,856,400. And that's square kilometers. And multiply that by 4. This will be 23,425,600 pi square kilometers. So here, that is going to be the surface area of a certain planet, which is, of course, a sphere. And finally, a liquid covers approximately 80% of a planet's surface. Assume the planet is a sphere with diameter about 8,900 kilometers. What amount of the planet's surface is covered with the liquid? All right, we're given a diameter. The formula for a surface area of a sphere calls for the radius. So our radius, R, is going to be 1/2 the diameter, which is going to be D. That diameter was 8,900. So if I take 1/2 of 8,900 kilometers, I would get 4,450 kilometers. That would be your radius of that sphere, or the radius of the planet, which is in the shape of a sphere. And then we can find the surface area. Which is, of course, 4 pi times the square of the radius. So I'm going to bring down the 4 pi times 8,000, not 8,000, 4,450. The radius is 4,450. And that's going to be squared. So if I square that 4,450, I would get 19,802,500. And that's in square kilometers. Then I'll multiply that by 4 pi, and I will get 79,210,000, bring over the pi, and that's square kilometers. That would be the surface area of that planet. But I want to find out what amount of the planet's surface is covered with the liquid. And we're told that the liquid covers approximately 80%. Okay. So the amount of the liquid is this: 80% of the surface area. And 80% as a decimal will be 0.80. And the word of means I need to multiply 79,210,000 pi square kilometers. So if I take that and multiply it by 0.80, I will end up with 63,368,000 pi. 63,368,000 pi square kilometers. That area, that represents 80% of the planet's surface, which is liquid. Okay. All right, so that does conclude this video in section 13.4, dealing with surface area. Feel free to contact me if you have any questions about any of the problems that I presented in this video. Also, there might be a homework set on this, so feel free to use this as a way to help you do that homework set. And feel free to reach out to me if you have questions on that.